Okay, guys, let's look at number 8. And let's graph the parent function here, which is now a cosine graph. F of x equals the cosine of x. Okay, our amplitude, absolute value of 1 is 1. Again, that's found here in front. And our period, well, 2 pi over b, and b is found in front of the x. That's also just 1. The absolute value of 1 is 1, 2 pi. Okay, so I've got a period of 2 pi. And then what did I do? I took 2 pi and divided it in 4 parts. Pi halves. And if I'm starting here at 0, well, 0 plus pi halves is pi halves. And then add another pi halves to it. Pi and so on, 3 pi halves and 2 pi. Okay. So same process, and then what did we do? Well, then we evaluated. And again, the location 0, pi halves, pi, 3 pi halves, and 2 pi. And let's just do a couple. F of, say, 0 is cosine of 0. Well, what's the cosine of 0 on the unit circle? Well, cosine corresponds to x. I know at the unit circle where I start, and on the positive x-axis, the cosine of 0 is 1. Okay, so it equals 1. Let's do f of pi halves. Well, what's the cosine of pi halves, or the cosine of a 90? Well, there at the unit circle on pi halves, the x value is 0, so that'll be 0. How about f of pi? Well, that would be the cosine of pi. Well, what's my x value at pi? Well, that's -1. Okay, this is where knowing that unit circle makes it easy. And then 0 and 1, if I were to then evaluate my remaining ones. Okay, so once we evaluate, we're going to plot. At 0, I'm at, let's call this 1, -1. 0, I'm at 1. Pi halves, I'm at 0. Pi, I'm at -1. 3 pi halves, I'm at 0. And then 2 pi, I'm back here at 1. And so, again, it's got that shape of going into the trough. Sorry, that should just come down to there and back up. Okay, so that's my typical cosine graph. And notice cosine, when it's positive, the parent function is going to start, instead of at 0, 0 and go up like sine, it's going to start here at the peak at 0, 1. And then it's going to go down into that trough and back up and finish at that peak. Okay, so again, this is, remember, a different starting point here for the cosine. Okay, so that's my parent function, and again, I would go through these same steps that I've been going through each time to figure out what that graph looked like if I wasn't sure. All right, now let's look at our next graph, which is a cosine graph, but it's transformed how? Well, that's a vertical shift up 3, you got it. Okay, notice it's not in with x, so that's outside, so that's vertical. And how about here? Well, that would really be a horizontal shrink of 1 over 5 pi. Okay, and how do we address that? Well, let's just do our same things. Amplitude, the absolute value of whatever's in front of our cosine graph, in this case 1, is still 1. Period, which is 2 pi over the absolute value of b, So 2 pi over the absolute value of b here, which is 5 pi. Okay, so 2 pi over 5 pi, the pi's cancel, and again, the absolute value of 5 pi is just 5 pi. The pi's cancel, and so my period is 2/5. Okay. All right, so now when I go to actually graph these things, I want to then start with this vertical shift up 3. Well, I want to go up 3, and I want to put in that what? You got it, that midline. Okay? So I'm going to go ahead and dot in my midline here. And that's y equal to 3, and that's my midline. Okay. Then, what do we do with our period? Well, we divide it in how many parts? You got it, 4 parts. Well, dividing by 4 is the same as, say, multiplying by a fourth, if I want to look at it that way. So, 2 over 20, which equals 1/10. So that's the amount I'm going to add to my starting point each time, and to each location as I go until I get to, say, my 2/5. Okay. Okay, so let me erase. Okay, so 0 plus 1/10, 1/10. That's going to be my first location after 0. So, and I'll just go ahead and put this in a minute when I come back here, and I'm going to evaluate locations x, comma, y. 0, 1/10. Okay, and then how much am I going to add to 1/10? Well, 1/10. What's 1/10 plus 1/10? Well, 2/10, which is 1/5. Okay, and then from that 1/5, I'm going to add 1/10 to it. And remember, 1/5 is just 2/10. 2/10 plus 1/10 is 3/10. And then add another 1/10 to that, which is 4/10, which reduces to, you got it, 2/5, where our end period would end, 2/5. Okay. Okay, so once, whatever my period is, in this case I did 2 pi divided by 5 pi to determine my period, 2 pi over the absolute value of b. Whatever that value is, I divide by 4 or multiply by a fourth to figure out how much I'm going to add to whatever my starting point is each time until I get to the end of my period. Okay, so let me erase. Okay, and then we're going to evaluate these points and just kind of confirm some values. Oh, and of course we can plot them. And 2/5 is approximately, the whole period is 4/10, which is, really would be in this space, like right here, between here and here. Right? That's not very much. So I'm going to just go ahead and extend it a little further, because in order to see it, I'm just going to kind of change my x-axis scale a little bit here. Okay. So, but let's just go ahead and say, call this Let's just do our 4 locations. And remember, it would really be horizontally shrunk even farther than this. It would be a real small period, but I'm just going to somewhat expand it here. And again, I'm going to make it shorter just to show that it is shrunk like that here. Okay, and here my locations. Sorry, let me put them on here at this location, midline of 3. So 2/5, 3/10, working backwards here now, 1/5, 1/10, and again 0. And let me erase. And remember, really all of these would be way more shrunk than this. I'm just making it this large in order that we might see it. Okay. Okay. Let's evaluate. G of 0, cosine of 5 pi times 0 plus 3. Okay, so 0 times 5 pi is the cosine of 0 plus 3. Well, what's the cosine of 0? Well, 0, the cosine, the x value there is 1. 1 plus 3 is 4. All right, g of a 10th. Cosine of 5 pi times a 10th plus 3. Well, 5 pi times a 10th is the cosine of pi over 2 plus 3. All right, what was the cosine of pi over 2? Well, 90, the x value there is 0. 0 plus 3 is 3. Okay, g of a 5th. Well, let me erase. G of 1/5. Well, cosine of 5 pi times a 5th plus 3, which would be the cosine of pi plus 3. Well, what's the cosine of pi? -1 plus 3, 2. 2. And then if I evaluated my other locations, I should come up with 3 and then 4. Okay, let's plot those. 0, I'm at 4 here. 1/10, I'm at 3. 1/5, I'm at 2. 3/10, I'm at 3. And 2/5 here, my final location, I'm at 4. And then again, I want to draw my shape. Okay, so notice we've got a horizontal shrink. That's what took the length from here, the period length, to there. But really, our period length would really be about this long, from here to there. So it'd really do that whole thing in a probably about that space. But I changed my scale a little between the two so that we could see it. But what happened was the period length, instead of being, say, from here to there, got shrunk down from here to there. Okay, and I made it a little bigger just so we could see it. So we've got a horizontal shrink of 1 over 5 pi. We've got a vertical shift up 3. Notice all of our action is taking place around this midline of y equal to 3. And remember, we want to account for that first if we have a vertical shift by drawing in that midline. And then notice I took whatever my new period was, divided it into 4, and added how much to 0, which was my starting point each time, until I got all my locations and then drew my graph. And it's got an amplitude of 1. Okay, so and remember, this would be even more shrunk than it is here. Graphically, I just did it to kind of be able to see it. Okay, let's look at the last one.